Great, thank you, Lee. That's all right. So thanks to the GSM Symposium for having us in. Myself and the rest of our Nevada team are all pretty excited about McCoy-Cove and look forward to any chance to play show and tell whenever we can. Today I'm going to be talking about case studies of exploration geophysics at McCoy-Cove. And I'd like to thank Neil O'Neill and Warren Thompson as well for their input in putting everything together, as well as Jim Wright there in the back. He's processed all of our data up till now and done a fantastic job. So been bouncing ideas off of him the last month or so. Right, haven't seen one of these yet today. Typical disclaimer. I'm going to be proactive and add in a little bit of one of my own. I'll be the first to admit that I'm far from a geophysics expert. Looking forward to the Q&A and everything that goes along with it. But if it starts getting to nano Teslas and line spacings, I tend to maybe fade off a little bit. I'm just thinking about golf, so don't get too worried about me. Okay. So McCoy-Cove, a pretty well-known historic mining property. It's located 35 miles south of Battle Mountain on Highway 205. With the 100% acquisition of McCoy-Cove from Newmont in 2014, we have a pretty significant land package now, 12,400 hectares or roughly 31,000 acres, so a pretty big sandbox to play around in. Between McCoy and Cove, there's been past production of 3.3 million ounces of gold, give or take, and 110 million plus ounces of silver, with the lion's share of that coming from the Cove deposit. So before we get too far ahead of ourselves, we probably need to understand the geology a little bit before we can interpret the geophysics. So here's a strat section prepared by Marcus Johnson in 2003 for his PhD. It just shows the Triassic carbonate package and classic sedimentary rocks that are sequenced over the volcano Lockthon. The whole system is capped by, the whole system is capped by this tertiary volcanic rocks. We call it the Tuff Cove. And then you work your way down through the strat. You have the McCoy deposit right here. You have McCoy actually stretches down a ways into the Smelter Pass. You have the Cove deposit in the Smelter Pass, as well as in Panther Canyon, and then the discovery of the upper and lower Helen zones in the home station of Favorette in 2010, I guess, by Victoria. Before that was probably Newmont with the Beta zone. So our newest discovery is the 2201 zone, which is down in the Dixie Valley, which is almost identical, classic sedimentary sequence to Panther Canyon and Minor Cove. Iron ore type is almost identical as well. So just pretty neat. I'm not going to hit that one. So simplified geologic map. Take anything away from this one, I want to focus on our blue and green, which is the Triassic carbonates. That's where most of the ore is hosted on the property. Down in the bottom right, you have the purple, you have the Jurassic McCoy Pluton. Pretty dry, hasn't really had any economic significance, although it definitely probably was a heat driver on the property. As well as the Eocene brownstock in orange there, and that is the really important stock for any Carlin-style system. So you can see the McCoy and Cove pits right here, and we're hoping to turn that into one big deposit one day. See how much drilling we can get done. So like any good deposit, you should have complex faulting, provides pathways for fluids and mineralization, and it never hurts to have folds. So we have quite a few anticlines and synclines in the property, with the biggest one obviously focused on the Cove pit, called the Cove anticline, where you get the intersection of these north-northeast structures with the anticline. You get great mineralization going along stratomound beds. So we're not really reinventing the wheel, I'd say, with our interpretation of mineralization styles. We believe it's an evolving porphyry system, both prograde and retrograde mineralization over time. We're going to start with the skarn, McCoy, gold, silver, pretty hot, classic skarn, pyrrhotite, magnetite, garnet dioxide, lights up like a Christmas tree with the right geophysical methods. So, we'll move on to polymetallic sheet sulfides. This is what hosted this is what the Cove pit was, the sheet of polymetallics, plus or minus, gold, silver, plus or minus zinc, lead. still in the prograde porphyry phase, but it is cooling a little bit. And we interpret this as distal from the main system, which is obvious. The ground stock and the skarn of McCoy are obviously the locus of your mineralization that's spreading out to the northeast along those structures. One really interesting thing we see with the polymetallic sulfides is at the, swing back here, at the contact between the 2201 zone and the Fabric limestone, you actually get mantle mineralization, which is, we do get some high grades, a lot of really strong base metals and silver and stuff going through there. Probably not economic at this point, but it sure looks cool when you drill both of them. So. And lastly, we have the Carlin style distal disseminated gold plus or minus silver. This is part of the interpreted as the retrograde phase to the cooling porphyry system. Low temperature, pretty standard with what you kind of expect to see with a lot of Carlin systems. And you do see an argillic cap forming along all of the intrusives that extend out along the Gold Dome Bay, all of these northeast structures. End result, decarbonatization, sulfidation of gold. Pretty classic Carlin. So now that we understand the geology, what does it mean for geophysics? We've had 5 geophysical methods throughout almost 40 years of exploration and production on the property. Induced polarization done by Tenneco, Echo Bay, Premier Gold, ground and airborne mag, mostly by Tenneco and Echo Bay, but there was a 2003 survey by Newmont, which we used quite a bit. Premier did Newmont as well as Premier done gravity surveys. We've been using our 2012 survey, and it's served us pretty well. And controlled source, audio, magneto, telluric, it's a long one. We call it CSAMT from now on. And we had 16 lines surveyed in 92 and 93, but that hasn't been processed, although it's something we do need to look at. And radiometrics, which were surveyed in conjunction with the 2003 airborne mag survey. So let's start with one of my favorite. We'll go with the IP. There was tons of lines done over the years. I'm going to focus on 3 distinct years, 1987, 91, and 2014. 87, there's 9 lines completed in and around the Cove pit, and these correlate very strongly with the soil sample anomaly that defined the 86 Cove pit discovery. So I guess Echo Bay viewed that as a confirmation. I don't know what the plans were, but it worked out well. So here you can see a depth slice of merged 2D inversions at 300 to 500 meters vertical depth, and it shows a significant chargeability high in and around the Cove pit. Now, this pit obviously didn't exist when this was taken, so you can't see the high extends right through. Then if you were to throw the 1986 soil survey on there, it really correlates really strongly. So this was the soil sample that discovered the original Cove pit discovery, obviously correlates really well. Helen zone doesn't show up very well, but you'd expect that. Carlin style is distal disseminated, doesn't really do well with IP surveys, so, but it is there. And then off to the northwest, we have the Windy Point, which has some really great soil samples as well. Red, just for reference, is around 500 ppb and up, so we have some pretty strong surface anomalies. And that you can see there's also a pretty nice IP high there as well. So we are actually, we've been trenching in the early spring, and we'll be doing some follow-up drilling hopefully in late June or early July on that Windy Point target as well. Moving on to the 1991 Echo Bay lines. Again, 9 lines completed. We're going to focus on line 21, defined 400 to 500 meter deep by 900 meter long anomaly in the McCoy pit. And due to its proximity to the ground stock, we have to assume that it's very likely a sulfide skarn associated with the margins of the stock and the surrounding sediments. So here you can see an inverted chargeability chart, whatever you want to call it, sorry. So you can see that there's a really great anomaly right here. That's roughly starting at 400 meters depth, and it's interpreted that this is possibly an argillic / oxidized cap above there. That's why it's not showing up very strongly in the upper margins. Now, if you were to throw on the residual RTP mag over that, you can see that the mag correlates very well with the IP. Again, this is another one of our high priority targets since we acquired the property in 2014, and we built on that by adding in 3 lines to follow up on this anomaly. Line 2 and 3 extended the anomaly to the northwest at very similar elevations, roughly 400 meters vertical depth is where it starts. You see there's line 2 and line 3 right there. Line 1 was on the other side of the brown stock. Pretty much just killed that side of it, so what we expected. So as you can see, there's with this depth slice, there's a very strong chargeability high, roughly the same depth, 400, 800 meters. You'd expect that this anomaly should be deeper than what you see up at McCoy-Cove because all the strata is dipping very gently down to the south, so it makes perfect sense that we're roughly 300, 500 meters up here, 400, 800 meters down here, whatever is going on, which we interpret to be possibly polymetallic sheeted sulfides that are extending out along the gold dome and bay structures, which are known mineralizers for both McCoy and Cove and Helen deposits. So this is our highest priority target right now. We're drilling just pre-colored a hole right here. It's going to be going to 3,500 feet, so if there is something down there, we're going to find it. And then we have another couple starting up this way, and they're just pretty much going to be testing these structures at depth for similar mineralization to what we see in the 2201 zone here. Now, pretty much just summarize this all for you, so let's move on. Ground magnetics. The ground mag correlates really well with the airborne magnetics. However, due to the incomplete nature of the data set, it's kind of just sporadically little surveys here and there. It's really tough to kind of tie anything together. You can see, the Cove pit discovery there, brown stock, northwest intrusives right here, but just because it's so incomplete, we've chosen to just stick with our airborne mags and correlate really well. 2 surveys done in 96 and 2003. Get into spacing and stuff. But here you can see a RTP map that highlights the Cove top of the major lobe, which is something you'd expect. You can see down here, obviously, the EOC brown stock, a little hit right there, a little hit out in the pediment. But when Jim removed and masked the Cove tuff, it allowed us to highlight the weaker anomalies within the sediments. And I think this is one of the points that really needs to come out, if anything, in this talk, is if you don't have a firm understanding of the geology, you can't interpret the geophysics. Now, a lot, when I first graduated, I would have been like, wow, that's, we need to go drill this and this. And obviously that is mine, so. But this is actually the unaltered ground diagram of the brown stock that's sticking out there. It's actually the light green, the very subtle anomalies that are what you want to be looking for. So, for example, obviously M1, brown stock, that speaks for itself. It's a good target. M2, that's along the Lighthouse Fault, which is a post-mineral, interpreted as a post-mineral fault, and I believe that this is most likely a high related to the Jurassic McCoy-Cove, little squirt coming off from down below. Probably of little economic significance. We may follow up with some soil sampling, something along that lines, but I wouldn't put much stock in that target. M3, it's about the middle of the pediment, covered by probably a few thousand feet of alluvium, so obviously not a prime drill target. It is interesting though, could potentially be a felsic intrusive sill. We do see a lot of silling out along the Cove area, so probably won't be following up on that anytime soon. We can run short on targets, so it's worth looking at. M4 is actually, although it's a subtle anomaly, it's very interesting to me because this right here is the gold dome structure. And right at the Cove pit, it splays off to the northwest and it heads up, it cuts right through the Helen zone, which is mineralizing the main Helen zone. And then obviously it's covered by the Cove tuff here, but then it's previously been mapped up here as the Hidden Valley Fault. Now, looking at it now, we probably realize it's all one structure. But, so the gold dome splays up, hits the Hidden Valley Fault, and continues up northwest. That's definitely the best mineralizing structure on the entire property. Along with that is a mapped anticline right through here. Very, very similar to the Cove pit. So, although it's a very subtle anomaly, I would say that is our #1 mag target at this point. Probably due to the subtleness of it, probably something along the lines of more of a Carlin style target versus polymetallics. So very exciting for us. So we'll be working on that later in the year. M5, another subtle anomaly. Looks, I believe with Jim's latest IP round, we've come to believe that obviously the EOC brown stock extends up to the northwest at depth. And the northwest intrusive, as it's been called in the past, is probably just the surface expression of that deep And this subtle anomaly along here is most likely sulfide scar associated with the margins of brown stuff. So that obviously is it's been plugged quite a few times with a lot of different holes, a lot of different ways they've come at it, although like many Parliament style systems, it's been shallowly explored. So there is some interest at depth. Hopefully get a chance to figure it out. And this is one of the classic mag anomalies. It doesn't mean anything. Sorry, geophysicists there. But this has been drilled with condemnation drilling. It's just an argillized felsic intrusive sill with no economic value whatsoever. Just point that out more to be the devil's advocate. So since you're all on the edge of your seats after that, I will get down for later and maybe back later. Gravity. 2012, we did a almost property-wide gravity survey, 1,600 plus stations. Our main focus was trying to figure out the structure in and around the Cove pit area, especially with the Cove anticline, which you did an excellent job of. I'm going to zoom in on this image here. So here's the Cove pit, interpreted Cove anticline, heads up into the tuff, and then you can see with this gravity load, there's multiple offsets along the Cove anticline, and it's what everyone suspected. This isn't breaking the mold, but it does confirm that with this load, the Cove tuff infilled the weathered anticline of the Cove anticline, and that creates this significant load that you see. So the Helen zone is right about here. Helen fault comes up, offsets the tuff, or the anticline, goes up again, and the saddle fault does the exact same thing. So that's generated some, obviously for us, this entire trend along here is a fantastic exploration target for us. So we're hopefully going to be looking up some targets later in the year, and hopefully we'll have some success from it. Again, we're going to talk about it. Radiometrics. Not a big fan of radiometrics. This was done in conjunction with the 2003 Airborne Mag Survey. So what was done is we have looked at the data. Right here you can see equivalent potassium overlay in geology. The Cove tuff creates a natural high in the pit lake low. Obviously, the Cove tuff, the highs that you see with this are of no economic significance, although you do see a little hit up in here, or call it R1. Again, you throw in equivalent thorium, same thing, high, low, doesn't really get anyone excited. Although this R1 is still sticking up again, a little bit higher than what you expect, although there is a sniff of Cove tuff coming up here that I suspect is probably pushing that anomaly up. And again, you throw in the equivalent uranium, and that target is the only consistent target that breaks out over all three. This is a very low priority target for us. I highly doubt that we'll do much follow-up work other than possibly some soil sampling just to see maybe if something interesting comes out of it. And that's kind of one of the more like a rainy day target, not one of our high profile ones right now. So CSAMT. So we've had 16 lines surveyed in 92 and 93. Data is archived, has been processed. We do need to get it processed. Luckily, Jim Wright has generously offered to process it free of charge. So, right, Jim? We'll talk a little bit later. So that's a summary. That's 40 years of geophysics in about 12 and a half minutes, let's say. So obviously only just scraped the surface of everything, but what does it mean? Well, the IP, we accurately identified our sulfide mineralization at McCoy-Cove. It does excellent with both the skarn and the polymetallic sulfides. It's proven. There's multiple deposits, 2 of them now, that correlate very strongly to it. However, it doesn't do that great of a job of picking out your Carlin style mineralization, but 2 out of 3 ain't bad, so we're pretty happy with it. Mag highlights the Eocene intrusives very well all the way across the property, but you do have to be careful with you can really come up with a whole lot of anomalies if you're not sticking with the geology. So very useful. We'll continue to use it carefully moving forward. So gravity did exactly what we asked of it. Find multiple offsets in the Cove anticline. Probably won't be doing any further surveys. We've kind of gotten what we need out of it. It's a pretty advanced property, and we do understand the structure for the most part. So it's probably going to be shelved for now, but it's helpful. said, CSAMT hasn't been processed, so I can't speak to that. And if you couldn't tell already, I'm not a big fan of Radiometrics, so I don't anticipate pulling out those maps anytime soon. So, if we had to take maybe just one takeaway from the presentation, probably you'll regret saying this in front of a bunch of geophysicists, but be careful. I can't think of a quicker way to waste a few $1 million than walking out on a brand spanking new property with your fancy binder and all your new targets that your geophysicist has generously provided you with, and blindly drilling off your targets. If you don't understand the geology, if you don't apply the geology to your interpretation, you still could be successful, there's no doubt about it, but you're probably going to spend a lot of money getting there. That being said, if you combine your geophysics with your soil sampling, drill hole data, field mapping, any kind of just applying whatever data that you can, you're going to be able to have much higher confidence in your targeting. You'll be able to vector in some really excellent targets and hopefully get management to give you some money for once, which isn't easy right now. So yeah, it's been, our geophysics at McCoy-Cove, it's been very successful in the past, and we anticipate it to be successful moving forward. So, anyone have any questions? Oh, we'll talk about the CSAMT. Okay.
I'm just going to ask, when are you going to drill those holes in that really exciting target?
Yeah, they're pre-colored right now. So we're putting the first quartile out on next Tuesday, and it'll probably be about 3 weeks to drill the hole. It's a pretty deep one, but that's what's had us really excited about the last 2 months now. So.
Did you look at the resistivity at all that you got from the IP survey?
I personally didn't look at it. I'm sure that Jim probably has. Again, kind of just more skirting over the geophysics on the property, but it probably would be worth it.
It's my recollection that Aradat flew a helicopter EM survey over Cove McCoy in somewhere around the mid-'80s. You don't have that?
Do you remember, Jim?
No, we can find all the things we've done.
Oh.
I had that.
I think it was Rick Taylor.
Did you?
They tested it out as a poster.
Oh, okay. Okay. Well, yeah. So we missed that one. I guess that.
And the resistivities from that survey mapped Cove. That was a problem. Had a little bit more of a problem with McCoy, and had several depth slices that showed it very nicely. So
Yeah.
I think you ought to find that data.
No, absolutely. Like I said, there's quite a bit of data here. So we're just kind of dipped our toe in over the last, let's say, year, give or take, but we have definitely more work to do. So. Anyone else? Yeah. Thank you. I don't know how I feel about that. Oh, okay.
There just was one thing. Some of your IP, you had depth slices that were 400 to 800 meters, and that's quite deep. And I was curious as to what primary survey parameters were, because we had discussions earlier today about getting out. You have to go quite a ways to see that deep, and so can you?
Well, I can't, but Jim can definitely help me with the technical side of things. But
There was 300-meter dipole in
what he said.
So the tops are down just over.
Yeah. We anticipate at least with the 400-meter depths, it does seem to pan out. There is some drill holes down right at that depth that shows some great sulfide skarn. We're talking half-ounce material over 20-30 feet. So the 400-foot level really does make sense. Like everyone has said already, the deeper you get, the less confidence you have in it. So that's why we're throwing a 35.
It was 400 meters, and the slice was 400 to 800.
Yeah.
800 doesn't come easy. Just sort of like you gotta work to get that.
Oh, sure. Yeah.
Continue the second part of my question. So, Judd, let's say you get promotion tomorrow to CEO.
Yeah.
Both funny decisions. You've got a lot of historic geophysics, they're throwing everything at it. Clearly, you're familiar with the radiometrics. But of the rest of the techniques, would you use them all again? Would you use one only?
No, well, I mean, I think we've used multiple methods. Obviously, the gravity pretty much covers what we needed. The IP's been great. I'd like to see us either work on some more of the lines that are up to the northwest of the Cove pit with Jim, and if necessary, put in some deep seam lines, because we do believe that there is some good mineralization right at that similar cove elevation in the Panther Canyon, which may or may not be picked up by some of the other methods. So at this point, like Jim mentioned earlier in his presentation, we're kind of at that level right now where we're done with the geophysics, the soil samples. We've generated more targets than we have money to drill. So right now it's kind of let's test them, and then if they don't pan out, we'll go back to the drawing board and see. But right now we got probably 2 years worth of drilling before I'm too concerned about running out of targets. So. All right. Thank you.